Now look at number 2. For the quadratic function defined at the right, write the function in the vertex form again. Write it in the vertex form again. Give the vertex. So, okay. So the first thing I want to do is throw the constant term to the left hand side. The constant term is -1. So I will now say +1. That means +1 on both sides. 1 plus p of x is equal to whatever remains in the left hand side. -x² minus 3x. Actually, it's plus there. And if I like, I can take away, I can put negative outside here. So negative outside x² minus 3x. Okay. All right. So now I am working because I put this negative here. I'm going to put it here. Divide the linear term, the coefficient of the linear term by 2. So I have -3 here. If I divide it by 2, I don't want to write 1.5. No. So I'm going to carry on with. So I'm going to write -3/2 squared. Okay. And whatever I do to the right hand side, I will do it to the left hand side. I want you to know that I took negative off. So when I am trying to I'm going to square this and I'm going to bring it here. And that is 9. Actually, it's actually 9/4. So I'm going to write 9/4 here. But I want you to remember, because of negative here, I'll put -1 plus 1 that is already here plus p of x. And then the next thing I want to do is open the parentheses. I have x, take one of this here and take one of that, 3/2. And that is square outside. Simplify what is in the left hand side. So 9/4 plus 1 is the same as 9/4 plus 4/4. That means I now have 5/4 remaining on the left hand side, and it's negative. So if I add 5/4 on both sides, I have plus 5/4 here. 5/4, not 5/5. So I have 5/4. At this point, I can actually write it as a decimal, 5/4. Therefore, the function is now looking like a vertex form. The function is looking like a vertex form, so I just have to write the function notation. All right, so the leading coefficient is -1. In other words, the graph I will have will be a maximum. If the leading coefficient is positive, the parabola is a maximum. And what do we mean? Concave down. This is a maximum, concave down. If the leading coefficient is positive, the graph is a minimum, concave up. All right. So when the leading coefficient A is greater than 0, we have minimum. When the leading coefficient is concave down, it's a maximum, x or a leading coefficient is less than 0. Okay, so now we have converted it from the regular to the vertex form. We can be told to find the vertex, and the vertex will be 3/2 and 5/4. And then if you like, you can actually put this original equation in the calculator and check your answer. It's always good to, if you're told to show or work, do it analytically. That's fine. But if you have a calculator, that helps you a lot. Plug this equation in my y1. Plug the equation in my y1 and look for Of course, whenever you look at this equation, it has a negative leading coefficients. You already know it's going to be a maximum. The parabola will be concave down, so it's a maximum. Okay, so the graph has to look like this. But what you're looking for is the point at the top, the maximum point. So I'm going to put the number or the equation in y1, negative x squared plus 3x. Because people make mistakes, you want to check that your maximum point corresponds with the maximum that the calculator give you. That the calculator you're going to have from the calculator. So they don't have to ask you to use calculator, but you want to make sure you know that you can use calculator. So I think my windows are good. So I can just sketch it, see if I'm going to have what I need. So I see it's a maximum, and I'm looking for the maximum point. So how do I find the maximum point? I will ask my calculator to give me. How do I ask my calculator? You do second calc. I already know it's a maximum. So I'll select number 4. Now I'm asking my calculator to give me the point at the top, the maximum point. And my calculator is asking me, is this the left bound? Yes. Select that. And I'm going to arrow to the right. And that's the right. Is that the right bound? Yes. Do I guess the maximum point for you? Yes. It's going to be some kind of fractions. All right. So you see that answer is good. You can change your answer to decimal. So it's 1.49, approximately 1.5 and 1.25. The maximum point, in other words, the x and y coordinate at the top there is. So don't forget to check your answer, especially whenever you're told to find the maximum point, the minimum point.